Alright, so we're going to pick up with another example here of graphing a function using the stuff we've been working on. Alright, so that was where we stopped yesterday, was the function of 2x squared minus 9 over x squared minus 4. Okay, do one today, it might be a little bit easier. We're going to look at this guy. X squared minus 2x plus 4 over x minus 4. So first off, let's find the derivatives. So first derivative, f prime of x. After you do the derivative and then you simplify a little bit, you're going to get x minus 4 over x minus 2 quantity squared. Yeah. And that would just be, low d high minus high d low over the square of what's below. And then I simplified a little bit. Okay. F double prime of x. So just applying it again, I'm going to end up with 8 over x minus 2 to the third. All right, x-intercept. X-intercept, I would set it equal to 0, right? Can I factor the top here? I don't think I can. 1 and 4, 2 and 2, the one gets me negative 2. All right, so we'd end up with a really, really ugly, really ugly, oh crap, quadratic formula is how we'd have to do the top. And then we still have it over the bottom. All right, but I'm going to help you out a little bit. There's going to be no x-intercepts. All right, no x-intercepts here. All right, so then from there, y-intercept, I put a 0 in for x everywhere, and I'm going to end up with 2. Okay. All right, horizontal asymptotes. We actually do not have any here. No horizontal asymptotes. Do we have a vertical asymptote? Sorry, I wrote this wrong. My y-intercept is negative 2. Let me just rewrite that. My y-intercept is at the point 0, negative 2. My vertical asymptote is at x equals 2. Okay. Let's talk about end behavior a little bit. So end behavior, the limit as x approaches negative infinity, well, it's just going to be infinity because you're going to have 1 over x over 1 over x. And all right, when we do those limits like on that worksheet, it's approaching negative infinity. This is the end behavior here. The limit as x approaches positive infinity. This is going to be positive infinity. All right, our critical points. Negative 8. Negative infinity. I buy it. Yeah. Better? All right. Certain behavior. Now, critical numbers. Critical numbers are what values give us 0 or undefined when we set f prime of x equal to 1. Well, on top, if I have a 0, it's going to make it equal to 0, right? And if I have let's say a 4, I have a 4 minus 4 on top would be 0. Okay, so that'd be a critical value. All right, so my critical values are going to be x equals 0 and x equals 4. And again, that's the values where f prime of x would be equal to 0. All right. Inflection points. Talk about those. There are none. And then the domain of it, domain's all real, but what's the one value that would make this illegal? What value on the bottom? What value here? If to make that 0, what would make that 0? 2. Right? So, look pretty good there. All right, now we need our chart. We can do all our intervals. All right, so we have critical values of 0 and 4, but also have that vertical asymptote at 2, so we're going to use each one of those. All right, so we'll go negative infinity to 0. We're going to go at x equals 0. We're going to go from 0 to 2. We're going to go at x equals 2. We're going to go from 2 to 4. We're going to go at 4. And then we're going to go 4 to infinity. Okay. So we need our function value for some of these. We'll need our f prime of x for some. We'll need our f double prime of x. And then our characteristics. So here we go. Boom, 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 boom. All right, so first one, from the interval of negative infinity to 0, I don't really care about f of x. All right, if I plug in a value, so let's say negative 1. If I plug a negative 1 into f prime, I get positive. Plug a negative 1 into f double prime, I get a negative. Because it's a positive at f prime, it's increasing. Because it's negative at f double prime, it would be concave what? Concave down, correct. All right, at x equals 0, the function is just negative 2. F prime would be 0. So that's actually a minimum value because it's negative. And because it's 0. All right, from 0 to 2, let's plug a 1 in. Plug a 1 in, I get a negative here and a negative here. What's my outcome because it's a negative on the first derivative and second derivative test? It is what and what? Increasing or decreasing? Decrease. Concave up or down? All right, at x equals 2, I end up with undefined across the board, but that's my asymptote, so that's what it should be. Okay, that's my vertical asymptote. 2 to 4, I'm going to put in 3. I don't care about f of x. What I do care about is the next 2. I put a 3 in. That's going to be a minus. That's a plus. Increasing or decreasing? Good. Decreasing? Concave up or down? Concave up. At x equals 4, I'm going to have 6. When I plug that in the original, I get 0 at f prime of x. Therefore, it's going to be a critical value. It's going to be a min or max. It's a positive number, and it would be positive at this value as well. So therefore, it would be a relative min here. All right. Actually, I made a mistake. This should be a relative max up here. Relative max, relative min. Okay, last one, 4 to infinity. Plug a number in, put like 5 in. You get positive f prime, positive f double prime. Therefore, it's going to be increasing and concave up. All right, so we have to be able to take all that information into account whenever we take this guy. I'm going to get rid of this. All right, so we got to take all this information into account. So I'm going to draw my graph. Okay. So for my graph, first off, I have a vertical asymptote. I think those are the easiest things to draw. I have one of those at 2. Okay, so there's my vertical asymptote. All right, let's work on the left side now. The left side of the asymptote, I have a y-intercept at -2. Right? Now from there, it is increasing and concave down till I get to 0, and then it's decreasing and concave down as well. So the only way I could be increasing concave down, then decreasing concave down, will be something that looks like this. Right? It's increasing until I get to 0, then it flips over, and it goes decreasing, but it's still concave down. Right, then I hit my asymptote. Asymptote, there's nothing that exists there. After that, from 2 to 4, it is decreasing, but concave up. At x equals 4, I have a value of 6. And after that, it's increasing and concave up. It would look something like that. And we check the ends. This is going towards negative infinity. This is going towards positive infinity. Questions? Anybody? All right. All right, so this is what I want you to do. For this last one, okay? I want you to go through. If you can do it by hand, that's great. If you can't do it by hand, and you want to have Desmond's up beside you to help you as well, that's fine. This will be your homework for this section, okay? I want you to find first derivative, second derivative. I want you to find x-intercept, y-intercept, any vertical asymptotes, horizontal asymptotes, all right? I want you to do end behavior, critical numbers, the domain, and an interval chart, just like we did in the last two. All right. So that's what you can start right now. You can have the rest of the period to do that. And if you don't get it done, finish it for homework.